So, in the last classes, we learned about Keras versus TensorFlow, and we went through a problem statement in Keras, which was the MNIST dataset. So, what this did was it is used to identify handwritten digits. So we went through the code and we understood how to do this. In today's class, what you will learn is about TensorFlow. So first you should understand, even in TensorFlow there are two versions of TensorFlow. You have TensorFlow 1 and you have TensorFlow 2. So the TensorFlow 2 is integrated with Keras, and you can use a very large part of Keras in TensorFlow 2. The interesting thing about this is then that you can use some features of TensorFlow 1 along with Keras, but we need to understand TensorFlow 1.0. So why is that? Well, one reason is most research papers or most researches are based on TensorFlow 1. Okay, so you might be thinking, well, I am going to go for a corporate job. Why should I even bother about research papers? So here is the thing. You never know what problem statement you might get into, right? So you might get into a problem statement where you cannot find a specific part of the code. In that case, you might have to go and read a lot of research papers. You need to understand this, that this is actually a very big part. You need to understand the research paper and read research papers to understand more about your problem statement. In that case, if most research papers are in TensorFlow 1, you will have to understand what is happening. So even if you do not code in TensorFlow 1, you need to understand TensorFlow 1. It is very important because you have to understand different frameworks. So despite the framework, you can actually understand what the code is about. Okay, now let us start and introduce ourselves to TensorFlow 1. So since in the last class I showed you in my local Jupyter notebook, I thought why not introduce you this time to a Colab notebook and make you get used to more of Colab. Okay, so here you have TensorFlow, which was released as a library in 2015 by Google, and this is a lot based in on Python. So now what exactly TensorFlow does, what is the basic architecture of TensorFlow? Architecture of TensorFlow. Well, the architecture is more like you have a graph and you have sessions. We will understand more about the terminology in details, but when you were building models, if you remember in Keras, we used sequential, and then one after the other we added layers. These layers were predefined and there were modules in Keras where you could use these layers easily. But in TensorFlow you don't have such modules. You have to build it from the scratch itself. So what graph does it helps you build the whole model architecture. Once the whole model architecture has been built, you have to shift into a session, and it is in session where you can actually get the values and compute the graph. Okay, so this is the basic structure of a TensorFlow. So whenever you will be working with TensorFlow 1, you need to understand, you will first have to build a graph which describes the architecture, model, which will also describe the laws and metrics, optimization, whatever you have, right? So these are all the things that you will get with the architecture. Now let us look into and understand TensorFlow 1. Okay, so here are a few steps how you could install the TensorFlow in your local system. So what happens here is, if you look here, this is very similar. So you first create a TensorFlow environment. So you might have been using Conda, so you know how to create environment. If not, this is the statement to create environment. You can download Anaconda from its local website, and then you can create a new environment in Anaconda. So why do we need a new environment? Is because let's say I have a model that is working on TensorFlow 2 and Python, let's say 2.7 or something. So I'm using that. I don't want to disrupt that, but I also want to build another project which uses, let's say, Keras or something, or let's say TensorFlow 1 and Python 3.3 or whatever, 3.6 or something. So to keep this environment different from this environment, you can actually create a new environment. So this is what happens here is you can create the new environment. So once you create a new environment, you can activate that environment then. So once that environment is activated, it will act as a different computer in your system itself. So it will not mingle with all these your libraries that you were using in the previous environment. Here these are basic statements to download some of the basic stuff, like you have pandas, matplotlib, Jupyter notebook, SciPy, scikit-learn. You may not even want to download scikit-learn, I mean it depends totally. And then this is to install TensorFlow. So for this statement we will be using TensorFlow 1.14. so the statement is the same even for Windows. Now here in Colab, interestingly, Colab also uses TensorFlow 2, some version of TensorFlow 2. So even in Colab, if you are running this, you have to actually install TensorFlow 1. So here you can see I have installed TensorFlow. Now let us import TensorFlow and check the version. So you can see the version is 1.14. It gives this warning first, and then you will not get this warning anymore, like you can see here. So you can get the TensorFlow version 1.14. Now let us look into different. So the first thing, when you learn a programming language, you always learn about its variables, type of constants, data types and stuff. So here also we will start with the constant first. So to define a constant, you can use tf.constant. Now this is the same as let's say any string or number in Python. So you can describe a string as in, let's say, s equal to test. So this is the same. If this statement is written in TensorFlow 1, this will be the statement. Now you can actually print the value. So if you learn here, but oh, what is this? You have tf.tensor, some constant 0, some shape. What is this? I mean, this is not what we asked for. If we run this here, well, you get the value. So why are we not getting the value? Like I said, this is a graph. Remember graph? So you can only run graphs in sessions. So here you see we have this constant defined. Now we run this inside a session. You can call a session using tf.session, and session itself has a function known as run. This run means now the session is running and now you can finally get your output. So here it just describes you the type of constant this is, right? Now let us look into constants. So tf constant has these many values. You have a value here, parameter. In the value you can give whatever parameter you want. Data type, which by default it takes whatever data type it can recognize from here, but you can change the data type obviously. You have shape and you have name. So I have named this function as constant. Now let us understand tensor. So we have here, I have created different constants a, b and c. Now if I run these constants here, I have written the data type of these constants. This is float 64. Here I did not give any constant names, but here I have written different constant names. And so this is a, so now here is another thing. So this is C1 variable, but it has a name of C. This is C2 variable, it is also a constant, it also has a name of C. So if we run this, I get two names, C-0 and C1-0. So what this means is C:0 and C1:0. So since both of them have the same name, so the first time when this name is called, it gives that name. Next time this same name is called, it gives with an underscored 1. Now if I call this, let's say again, with name C3, and print it out. So this time you can see it gives _2. Then also again the next thing about here is we have a thing which is known as tf.graph. Here this statement is used to create any graph inside this. You cannot use this statement also. What you can do is you can just create here like this, like we did, and then you can run it inside a session. But for the simplicity we will be using a graph. So here you define the constant. There is another thing which is known as a name scope. So what name scope does is it groups all the variables inside, or all the values inside a particular group together. So what that means is, let's say you have a lot of variables. So I have, let's say, C here in some part, and then again another part, another C. So it will be _1, _2, _3 and all that. But to make it even more simpler, what we can do is we can group this whole together. So we can group this as, let's say, model 1. Or in this case what I have done is I have grouped them with the name scope of prefix name. So I can use prefix name. And now they are grouped. So if C2 and C3 are called at any time, like here, you can see they are under prefix name. So since this is named for the first time inside a prefix name, so it will start with again C and then C1. And you can see if I print only C1, it just gives me the whole thing that was given before. We have to actually run a session to understand the value of C1. Okay, so here again this is kind of a similar thing. I have defined a constant, but this time this is an array, and we run this inside a session and we get the value. So there were two ways of running a session. We can use with and run many things inside it, or we can just run the session in a single line. Since I am not using more than one line to run a session, I can just use this without a with statement. So here what happens is I am describing about session function and the idea of building a graph, also known as a computational graph. So what exactly is a graph? Let us talk about that. So graph in the basic sense means anything that has nodes and edges, right? So what does the graph mean here in TensorFlow? In TensorFlow, your nodes represent operations and your edges represent the data passing. So let's say I have a function to add 4 and 5. If I have to represent this in TensorFlow 1, it will look like, so this is a node, the functionality is add, and the data are 4 and 5. So this is my TensorFlow graph, and if I run this inside a session, the output that I will get is a 9. So this is basically a graph, and we have to run and understand a graph. Let us look into some more examples. So this is another computational graph. You have the input here a 9 and an input here 5. these are the edges, this is where the data will pass. Then it goes in here as A and B, and then it passes on again. These are the nodes. It will calculate the value here and give you the final value. So you have the input, mul is for multiplication, so you will have this data 9 and 5 pass into it, and you will multiply 9 and 5, you will get the output as 45. Next, here in add, what will happen is 9 and 5 will go in, you will get 14, and you add both of these and you get 59. So the nodes have been named A, B, C, D, E and stuff. So these names can be given. These operations or these nodes are known as op functions in TensorFlow. So this is all about the computational graphs. Okay, now let us look more into this. Here again I am running the same thing. Now comes the variable part. So right now what we have been looking into is tf dot constant. All these values are constant, but you have another option of tf dot variable. So here you have a variable and you have initialized it with any random value, any normal random value. That means any value that comes from a normal distribution. And you can run this. So before running you can print the value. Let us run this and see. So here before running I am printing the value format. So we have tf dot variable var and it gives the shape and the data type is float. So this shape is equal to the shape here because we are using this as the initial value. Okay, now one thing in variables is you need to use a global variables initializer. So what this does in every session is, so okay, first let us understand why this is there. So you need something and you need to define it before a session, a tf global variable initializer. Now let us run in with tf dot session as session dot run. You will need to first run this init. So this global variable initializer, what it does is it stores some memory in the session itself so that you can change the value and cache it and then you can run it again. So this is very important to run a tf global variable initializer. In the next part, now that you have initialized the global variables, now you can run. So in run you have tf dot variable. Now every time when you run this you will get different value for random values. So right now you have these values. If you run this again, the values will change. So this is what happens in tf dot variable. So if you want to reuse the same variable, right now it is changing, so you can use tf dot get variables instead of tf dot variables. Now the next part is tf dot placeholder. Now this is where you will feed the data actually. So you will feed the x values and the y values. In the model you were feeding at model dot fit. Here you will be feeding as placeholders. So you have x value as a placeholder here. Let's say tf dot string. So this is a data type of TensorFlow and x will be of TensorFlow dot string. And it is a placeholder. So what placeholder basically means is while running the session you have to give it a value, like we used to do in arguments value also while running or compiling a data. What you used to do is when you run the data at the same time you have to give it the value and it will compute at that time. So this is the same here. So you will use a feed dictionary here to feed the value into the placeholder. So if you don't do this, it will not give you the correct value. So here what I have done is the output is here and we are feeding x and the value of x is test. Now if we print the output we get test. What we can do is we can try the same thing again but without a feed dictionary. So like you can see here, I am getting an error. So you need to understand is It is very important to actually go and research and find out and keep changing different parts in a small program so you can understand the different outputs that you can get. Okay, so here now what we are doing is, here we fed one value as a placeholder. What if we want more than one value? So here I am showing different values. One is a string format, one is an integer, and one is a float format. In tf.session I am running and I am storing x, y and z into different formats, and we are getting outputs and we are printing those outputs. So why is it that I am only getting the value test string when I am feeding values x, y and z? You need to understand here what the output will be, whatever you put in here in the session.run. So even if I feed everything in the feed dictionary, the output will only be x. So you need to understand when running the data or when running the model, you need to feed the output as y or the labels here. So you will get labels as output. Now this is another thing here. This is again computation. So x I am using as a placeholder, and when I am running this I want the value of y, and since y is something that I have to compute, so I can just give a feed dictionary and give x values. So here this double asterisk means it's a power, so 1 square, 2 square and 3 square is given out. If I change this to 1, so now I'll get the values when they are multiplied with 2. Okay, now here I have shown a data table, and this shows about the different data types that will be used and how they are written in TensorFlow. Same thing. Okay, now let us come into the next part, the TensorFlow math. So we have tf.add function. Obviously it will give you the value of add. Add here is an op function. Then we have tf.subtract, multiply. So one thing you need to understand, again like Python, what happens is you have to give the same data types, otherwise it will not work. So here I am subtracting and they are the same values. So you have this. Now here there is another thing, I am subtracting a constant 2.0 with 1. So you can understand this is a float value, this is basic 1. So this will not run. It will give you a value error. See, sub op. Op means operation, like I said. So sub op, it has two data types that do not match with each other. So this operation cannot be done. So you have also this operation called cast. In this what will happen is this 2.0 will be cast as TensorFlow int value. Now once this becomes an integer value and you have this constant 1 which is also an integer, you will get the output. Now these are some other examples showing how we can run. Again, graphs are being created and run inside session. So it is very important to use TensorFlow.session here. Now we can understand about linear functions, how they can be used. We have weights, matrices, x, y. You have to actually compute and write all this. You cannot just use a layers module here like in Keras. So I am defining weight and I am using a normal. If you remember, we talked about weight initializers and how that can be used. So we had weight initializers. We had Hay normalization, Glorot normalization and stuff like that. We had basic normal initializers and stuff. So that is what we will be doing. So here I am initializing the weights with normal values, random normal values, and biases I am initializing as them 0, tf.zeros. Then we have feed dictionaries. So we define a as an addition of 2 and 5 and b as a multiplication of a comma 3. So the interesting thing here that I wanted to show is about feed dictionary. So if I run this session B and if I just run it basically without any placeholder, what should happen is a should get multiplied with 3. A is what? 5 plus 2, 7. It should be 21. But this will be different. So it should be what? 7 plus you add these two, you get 7, and you multiply it with 3, you should get 21. But what is happening is I am using a dictionary here, and here what I am doing is replacing a with a random 15 value. So I am using this as a feed dictionary. So now b will not use here this value of a, but it will use the value here that I have defined. So this will come out as 15. So now you have 15 into 3, which gives you 45. Now you have a softmax layer. You can build all these softmax layer using tensorflow.nn, which is neural networks for short, .softmax. So it is not like TensorFlow you have to build everything. There are some things that you can use obviously, but then again you can build softmax layer on your own. You know the functionality and everything. Then you have cross entropy. Cross entropy, what is this? It's basically minus summation of yi log of yi hat, right? So you are basically reducing the sum. So reduce sum is basically calculating the mean, and you can use the log function and find the actual values. No big deal. So here what we are doing is we are using cross entropy. So we have softmax data, that is the value that we get from the labels. So you have, and then you have one hot encoding, that means these are the actual values. So the first value is 1 and other values are 0, that means the label is the first label. And the softmax layer you have 0.7, 0.2 and 0.1. So the highest value is 0.7, so it should give us some probability in softmax. Let us look into that. So cross entropy is basically reduce mean, which is mean, reduce sum, sorry, which is mean, and you have a minus sign here, that means negative of, because we are finding out the cross entropy. Then we multiply one hot encoding with log of the softmax values, because that is what we are doing here. And then we run this, and what do we want? We want the cross entropy here. So cross entropy is basically what? It's a loss function. So we can print out a loss function now, which is 0.35. So now we can understand whether we need to improve our model or do something else. Okay, so this is all about TensorFlow. In the next class, what we will do is we will go through this MNIST data set and how this can be done, but using TensorFlow 1 this time instead of using Keras. So you can finally embrace how amazing Keras is and how easier it makes everything. Okay, so that's it. Thank you and keep learning.